Well, hello everybody, and welcome to part 2 of our series on the Ampeg Gemini 2 guitar amplifier restoration. In the last video where we ended up, we completed the rebuild of the power supply, the bias circuit, and we redid the outputs, and of course we biased and fitted the tubes and checked the output section so that to make sure everything's working. Now, on these kind of tube amps, you can do that, and I don't know how everybody else does it, but with my method that I prefer to do is I like to start at the power supply and then work my way back from the output back to the preamp. And the reason you can get away with that on these types of amplifiers is, if you notice, everything's capacitor coupled, so none of this is necessary for these tubes to bias up and work as if they do without all this in there, or with all this in there. So that's what I like to do, and then I just go to each section and test it as I go back. Now, strangely enough, I noticed another issue with this amp, another mystery that I just can't quite understand how it worked. When I first received this amplifier, and I know it was nothing that when I got it that was changed. It must have been that way for many, many years. But if you notice, there is a 150K resistor going from the 16 ohm tap of the output transformer, and that's what's giving us our negative feedback to the pentode section here and of this 7199. Now, here's the mystery: is these two wires originally just came straight out of the side of the transformer right here. You can see there's the yellow wire and the black wire. They just came straight down and were big long wires, and they went all the way down directly to the speaker, and they connected to the speaker. Now, if that's the case, then this was never grounded, because the speaker is actually mounted on the baffle, which is wooden, and there would be no way for this wire to be tied to our ground. So essentially, this amp has been running all these years with no negative feedback, because technically this isn't going to do anything unless this is grounded. So another very strange situation. So what I've done is I've fed those two wires up through the grommet, and I fed them along here, and these two eyelets were empty. So I went ahead and I put the, just tacked them in for right now, the wires in there, and I mounted this socket right here, and I'm going to just connect a couple wires over to here. Now, strangely enough, we do have the feedback circuit. Here's the green wire, which is your 16 ohm tap. Here's your 150K resistor, and it goes back here, and this follows back to, let me see here, this yellow wire, which goes out to here. So you can see it kind of, this wire ties over to here, this ties over to pin, what is it, 9, 8, 7, pin 6, which would be pin 6 right in here, and then goes through this point 1 to pin 3. So here's the point 1, and it comes around and goes over here and down here into pin 3. So it is in this circuit, but I don't know how that ever could have been if there was no ground wire connected here. So again, very strange. This whole amp is the more I work on it, the more things that don't make sense, and how much of it was done at the factory and how much of it was done aftermarket. You know, somebody had worked on it at some point in time. I don't know. But anyways, I'm going to go ahead and connect these up, and then we're going to put the tubes in and just see what this amp does. Okay, so I'm sorting some of this stuff out now. I do have the speaker connected up properly and everything, and I just did a quick test. I plugged the guitar in real quick, and the amp works fine. It's really silent, almost no hum, but the amp does not have any gain. It's just, well, Ampegs are supposed to be very clean, and they're known to not have the kind of gain as some of the other ones, especially like the Marshalls and even the Fenders. But in this particular case, I think the reason that it was a little bit louder before was because that ground lead for the speakers, for the output of the output transformer, was never tied to the chassis. It was never tied to ground. So therefore your feedback was really not doing anything. Now that it's connected, we're seeing the effect of that feedback. Even though it's not real heavy feedback, there is some feedback. The other thing is, this is really interesting. Once again, this amp here deviates from the schematic that so far has matched this amp. Now that we're at the preamp section, some of this does not match. For instance, let's see. When I have this schematic, which obviously has the different power supply, these seem to be a little more in line. Like, for instance, if we look up here, all of the coupling capacitors between the stages, if you notice, are 0.1 microfarad or 100 nanofarad. If you look at the schematic here, they're 0.022 microfarad or 22 nanofarad. And so those things certainly don't match. Now, this part here matches in the beginning, in the front end, and some of this matches. However, this is closer to the actual circuit, even though this one's got the wrong power supply. This version, and I don't know which version this one is because it's not marked. This is for a G12, not a G15, but the front end of this is anatomically is almost perfect with what we have up here. So it's almost like it's a G15 output section with a G12 front end. And again, the amplifier very specifically says, if you can look here, model G15. It is not a G12. So this amplifier is so interesting because it just doesn't match any one version of any Ampeg amplifier. It's really weird. There's just differences. This does not look factory. I mean, hanging up here by this big wire, this is for the reverb circuit, and this is the 6CG7 tube. It's supposed to be a 10K 5 watt. This is a 10K 10 watt. Obviously has been replaced and just kind of dangling by the wires here. So again, I'm just not sure. I almost just have to redraw this whole thing out because it doesn't seem like, it just seems like they took bits and pieces of all the different versions and made this amp out of it. So I find myself kind of just going through and rebuilding it almost, because once again, with that feedback, both channels now don't have the output that they should, or don't have the gain. And of course that's because if you plug these numbers into a 12AX7 gain calculator, you'll see this gain is very low, somewhere in the 30s. Okay, a lot of progress has taken place since the last video clip, and I think the very last one may have gotten cut off. I'm not sure. Won't know till I go to edit this thing. But let's kind of go through the thought process, what what we found on this. First problem I ran into was all over the inside of this amp. There was asymmetrical clipping. In other words, when like the preamp and driver stages would go into clipping, it would clip on one side of the waveform long before it would clip on the other side. And that was due to a bunch of different problems, actually. The first issue was in the main 7199 driver and phase splitter circuit. It had a bad resistor. So if we go to the schematic, and yes, I have final schematics drawn, this resistor, which one was it? I think the 470K right here. This resistor was wide open, and all these other surrounding resistors were out of tolerance. Some of them not a whole lot, but all of them a little bit. Some of them a lot more. So this whole bundle of resistors, as you see, had to be replaced. And I didn't change or modify the values, just replaced them as is. Again, the capacitors were perfect. Now, one of the things I did do, since this is truly a two-channel amplifier, it does have two separate channels. If you look at the preamp, you know, channel 1 has its own little preamp and channel 2 has its own preamp. I heavily modified this one. This is a straight through channel. It doesn't go through the effects. This one, if you notice, goes up into the reverb and into the tremolo circuits. So I left this side pretty much stock. I just replaced the components that needed replaced. Left even this tone module I left as is. Up here we built a completely different circuit, and you can see where it is right here. First thing I did was I changed the amount of gain in each of the stages, and there's a lot of things that I could do different. For instance, in here I could put a grid stopper so that when this goes to ground, it doesn't totally send the grid to ground. But so far I've not seen any problems with that. You can play with these two values here. This turned out to be perfect for what I'm looking for, which is like a single coil type pickup or something like that. This front circuit is kind of copying the way that the old Fenders did it. And you can see, if you really look at this, if you plug a guitar into this port and not this one, if you notice, what it's doing is it's lifting this one off. So you're taking it off of the ground, because see, it kind of grounds through this one. However, you're feeding through here and into here, and you're allowing this 68K here to go to ground. So you basically have a voltage splitter, kind of, where you have 68K as your grid stopper, and then you have another 68K as like a grid leak. Now, if you plug your guitar in this port instead, then what you're doing is you're putting a 1 meg up front here, not back here, and you're essentially putting these two 68Ks in parallel, which is giving you a what is it, 34K. So it's kind of an odd design, but it's something that Fender used, and I like it, and it kind of gives you some options, and it seems to work really, really well where it is right now. So, and then I kind of rebuilt the Fender circuit here a little bit for the tone control. And again, these values do not match the Fender values. It's kind of an amalgamation of different things. But what happened was everything is perfect. So I have just a really slight 50 millivolt RMS. So it's 50 millivolts RMS signal feeding into the guitar port, and you can see it up here. And if you look at the output, so I'm checking, I have my scope attached right now right here to this output. So right here, before it kind of right where it's going to go into the tone stack. Okay, and if you look at that, you can see perfect sine wave. No clipping or anything, it's perfect. Now let's move our scope over to the next stage after the tone section. Okay, I'm now looking at the output of the second tube, which is right here. And you can see there's some pretty crazy gain going on there. I did this on purpose. The other channel's very quiet and very mellow. But if we go over to our scope, the blue trace that you're going to be looking at is the output of that driver, of that preamp tube. The yellow trace is actually your 8 ohm dummy load where the speaker would be. So if you take a look, and you can see it's really good, and it kind of follows, and right where it starts to clip you can see the amp clipping, and the amp is clipping at about 33 watts. So getting 33 watts RMS into 8 ohms from 27591s, and I'm not biasing it really hot either, by the way, is really, really good for 7591s. That's about as hard as you want to drive those. So I can get high gain, I can drive it into clipping. Obviously there's enough gain on that front stage that if I put a hot pickup, you know, like that's putting a couple hundred millivolts, I'm going to easily get some crunch out of this thing, which is kind of what I'm looking for. The tone controls work really well. So if you turn this up, and I can turn the bass, you can see the bass really really cranks up. Treble same way, you could see. So those work perfectly, and they're spot on kind of where I want them. So that's it. Now if we move down the line now, let's check the rest of the stages. Okay, so if we look right now, I'm looking on this 7199 driver tube, and it's a pentode. Let's see if we can get it in the shot. Here's your pentode, and yes, I know I'm very close to the amp. I'm checking right here at the output where it's going to go into the second triode stage. So right here we're checking. You can see our scope probe down there, and you're going to see it's going to run in lockstep voltage wise with the output of your output tubes. So if we turn that up, you can see the yellow and blue lines are on top of one another, and you can see eventually it'll get ahead and then drive, but it's still very clean even though the output tubes are driving into clipping, and that's what you want. So there you go. So I can overdrive the amp from the input because of the gain of my input, or I can overdrive the amp at the output. Now, here's one of the big changes I made, and that is, if you look, let's move back over here. I changed this from voltage divider bias to cathode bias. Originally, this 47K went right up to here to ground. This 1.5 wasn't here. This 1 meg went down to ground, and I think it was like a 1.5 or higher. And this was a 10 meg going up to here. So it was a voltage divider bias. I changed it because of the way this concertina splitter works. I wanted this to be a little more stable, so it, depending on which tube you put in, you know, if you go from tube to tube, I kind of wanted it to kind of stay in its center, stay better centered. So this helps it to stay a little bit better biased, I think. It's just my own opinion. Again, everything is just an option, what you want to do, what you prefer. So by having this is basically a unity gain stage. In other words, all it is doing is giving us the inverted phase. And so whatever voltage is here is exactly the voltage that's going to come out here, because this is unity gain. And if you notice, these are running in lockstep voltage wise with this one. So really all these tubes are doing is they're providing extra current. Okay, they're giving us the current we need to drive this transformer, to drive this speaker voice coil. And that's exactly what we wanted out of this. So again, all we're getting is an inverted and non-inverted phase to drive the two push-pull output tubes. And that's what we did. Now, I did also have to change the bias circuit a little bit for these tubes because they're pretty hot. I raised this from a 68K to a 78K, And really the way I did that was I just took two 39K resistors, and let's see if we can see them here, right here and here, and just put them in series, and that raised the voltage just enough that I'm right in the center of travel of that pot right here. And if you notice, let's say this pot goes open, let's say the wiper comes disconnected, what's going to happen is this resistor is actually shunting the voltage coming out of this limiting capacitor. So what's going to happen is, if this goes away, if any of this goes away, you notice we're coming directly off the output of this directly into our bias point. So what's going to happen is this is going to allow this negative voltage to shoot to its maximum negative, which is going to turn the tubes off. So it's kind of a fail-safe circuit. If this thing ever fails and goes open, by default it'll drive the negative voltage more negative, turning off these tubes. So, you know, one of the other problems with the other ones where you have an inline circuit, if you have too much, you know, if this fails, this negative voltage goes away, and this will shoot way up and it'll red plate your tubes. Theoretically, unless something goes wrong down here, we should never have problem with red plating, I hope. So there you go. So that's pretty much it. The rest of the amp I left stock, and I'm going to test it and make sure everything works on that end. And if everything's working good, then we're going to clean it up and we're going to give it a test. Alright, I just want to wrap this up with one last little change that I made. I swapped these around in the gain stages. Changed this to a 1.2K and this to the 2.7K. And the reason I did that was to make this a little bit less gain here and a little more gain here. I also, and that kind of to reduce hum even more. And the other thing I'm going to add is I put a resistor in here, a little grid stopper. I just didn't like the fact that when you drove this all the way to ground, you know, the volume knob all the way down, it grounded out that grid. So I just put this little grid stopper resistor in here. So just 3 little changes to the final design. The amp sounds great. It works great. It's exactly what I want. And I'm kind of at a standstill now. I just had my surgery a couple days ago. I'm really not supposed to be up around doing a whole lot, and I'm not going to be allowed to lift over 10 pounds for the next 6 weeks. So that kind of puts a damper on working on anything big. So I'm going to stop this video here, and when we come back to this project, I'm going to I got new Tolex covering. I'm going to redo the whole cabinet. We'll get the amp mounted, we'll redo the speaker and everything, and actually finally get to give this thing a really good test. I might even get out my old Stratocaster Fender to try it out. So again, thank you all, and I'm going to post this video as it is right now, and I will eventually post these schematics. It's 2 pages. Basically, we got the front end of the amp here, and the power supply and output section here. Everything works perfectly, and we'll go from there. For now, our new project that we're going to do in the meantime is something that I can pick up that's under 10 pounds. And I don't know if any of you have ever seen one of these before, but this is a Pioneer, and it is a model KP500, and it was an underdash FM radio cassette player. Believe it or not, these things they're collectible right now, and they sound incredible. I remember when they first came out, and they almost have home stereo audio quality in this little case. They're not real high powered or anything, but very, very well built. And we're going to convert this one and turn it into a bench radio. I'm going to change some of the connectors on it, and then we're going to mount it underneath the bench just to be able to listen to it and to have an audio source. I think it'll be a perfect project for that. So that's what we're going to work on. Again, thank you all. And I apologize I can't finish the amp right now, but it's I can only be up on my feet limited time, and then it starts to hurt a little bit. So we're going to wait till that gets a little better, and then we'll come back to our other projects. Until then, take care, everybody, and thank you all for watching. Thank you for the so many kind comments and for the donations that you've made. You all know who you are. I truly appreciate each and every one of you and all that you do and say, and I'm glad you all follow along. So take care, be well, and we'll see you next time.